Welcome to Educator.com. Today is our first lesson for the Algebra 2 series, and we're going to start out with some review of concepts from Algebra 1. If you need more detail about any of these concepts, please check out the Algebra 1 series here at Educator. So the first session is on expressions and formulas. Recall the earlier concepts of variables and algebraic expressions. So starting out with some definitions, a variable is a letter or symbol that's used to represent an unknown number. It could be any letter. Frequently X, Y, and Z are used, but you could choose N or S or W. Algebraic expressions means that terms using both variables and numbers are combined using arithmetic operations. So remember that a term is a number or a variable or both. So a term could be 4, that's a constant and it's a term. It could be 2x, it could be y squared. And when these are combined using arithmetic operations, then they're known as expressions. And when variables are involved, then they're algebraic expressions. For example, 4x cubed plus 2xy minus 1 would be an example of an algebraic expression. The rules specifying order of operations are very important, and they're used in order to evaluate algebraic expressions. Recall the procedure to evaluate an expression using the order of operations. First, evaluate expressions that are inside grouping symbols. Examples would be parentheses, braces, and brackets. The next thing when you're evaluating an algebraic expression is to evaluate powers. So if a term is raised to a power, such as 4 squared or 3 to the 4th, you need to evaluate that first. Next, that's the second step. Next is to multiply and divide, going from left to right. So you start out at the left side of an expression, and if you hit something that needs to be divided, you do that. Then you proceed towards the right. If you see something that needs to be multiplied, you do that. It's not multiply all the way and then go back and divide. It's start at the left. Any multiplication or division, do it. Move to the next step, move towards the right, multiply or divide, and so on until all of that's been taken care of. Finally, you do the same thing with addition and subtraction. You add and subtract from left to right. And we will be illustrating these concepts in the examples. One thing to recall is that a fraction bar can function as a grouping symbol. For example, if I had something like 3x minus 2x plus 2 all over 4 times x plus 3, I would treat this as a grouping symbol, and I would simplify this as far as I could, going through my 4 steps, and then I would simplify this, and then I would divide the simplified expression on top by the simplified expression on the bottom. And remember, the reason that we use order of operations is that if we didn't, and everybody was just doing things their own way, we couldn't really communicate using math, because people would write something down and somebody might do it in a different order and come up with a different answer. So this way, it's an agreed upon set of rules that everyone follows. Monomials. So a monomial is a product of a number and 0 or more variables. Again, refreshing your memory from Algebra 1, examples of a monomial would be 5y, 6xy squared, z, 5. So it says it's a product of a number and 0 or more variables. Here, there aren't any variables. So that actually is simply a constant, but it's still called a monomial also. Here I have 5 times one variable. Here I have multiple variables. So this is examples of, these are all monomials. A constant is simply a number. It's simply a number. So it could be -3 or 6 or 14. So those are constants. Coefficients. A coefficient is the number in front of the variable. So up here I said I had 5y and 6xy squared. This is a coefficient. 5 is a coefficient and 6 is a coefficient. When you see something like z, it does have a coefficient. It actually has a coefficient of 1. However, by convention, we usually don't write the 1. We just write it as z, but it actually does have a coefficient of 1. Next, degree, the degree of a monomial. The degree of a monomial is the sum of the degrees of all of the variables. So it's the sum of the degree of all of the variables. For example, 3x y squared z to the 4th. So if I want to find the degree, I'm going to add the degree of each variable. This is x, but that really means x to the 1. The 1 is unstated, plus y squared, so the degree is 2, plus z to the 4th. So the degree is 4. So adding these up, the degree for this monomial is 7. When we talk about powers, powers refer to a number or variable being multiplied by itself n times, where n is the power. For example, if I say that I have 5 squared, what I'm really saying is 5 times 5. So 5 is being multiplied by itself twice, where n equals 2. I could say I have y to the 4th. So that equals y times y times y times y. And here, the power is 4. Okay, continuing on with more concepts. A polynomial is a monomial or a sum of monomials. Recall the concepts of term, like terms, binomial, and trinomial. So a polynomial is simply an expression in which the terms are monomials. And we say sum, but this applies to subtraction as well. A polynomial can certainly involve subtraction. For example, 4x squared plus x, or 2y squared plus 3y plus 4. These are both polynomials. We also could say that, 5z is a polynomial, but it's also a monomial. So there's only one term, so it's a polynomial, but we usually just say it's a monomial. Okay, so looking at these other words, binomial. So a binomial is a polynomial that contains 2 terms. So it's the sum of 2 monomials, whereas a trinomial is the sum of 3 monomials. A monomial is simply a single monomial. Okay? Recall that, as discussed, a term is a number or a letter, such as a variable, or both, separated by a sign. So terms could be number, could be a variable, or it could be both. So 3x minus 7 plus z. So here I have a number and a variable. Here I just have a number, I have a constant. Here I just have a variable. And they're separated by signs, by a negative sign and a positive sign. So each one of these is a term. The concept of like terms is very important because like terms can be added or subtracted. Like terms contain the same variables to the same powers. For example, 1 and 6 are like terms. They don't contain any variables, so they're like terms. 3xy and 4xy are like terms. They both contain x to the first power and a y to the first power. 2y squared and 8y squared are also like terms. They both contain a y raised to the second power. And so those can be combined. They can be added and subtracted. A formula is an equation involving several variables, so 2 or more variables, and it describes a relationship among the quantities represented by the variables. And we've worked with formulas previously, and just to review, one formula that we talked about is the Pythagorean theorem. That is a squared plus b squared equals c squared, where c is the length of the hypotenuse of a right triangle, and a and b are the lengths of the two sides. And this tells us the relationship among the three sides of the triangle, and that's really what formulas are all about. And really a lot of what algebra is all about is describing relationships between various things. And of course, during this course, we're going to be working with various formulas. Okay, in this example, we're asked to simplify or evaluate an algebraic expression. So if I have x squared and they're telling me x equals 3, y equals negative 3, so I have some x terms and some y terms, my first step is to substitute. So everywhere I have an x, I'm putting in a 3. Everywhere I have a y, I'm putting in a negative 3. So here I have 3xy, so it's going to be 3 times negative 3. Recall the order of operations. The first thing I'm going to do is to get rid of the grouping symbols. So take care of the parentheses. And looking, I do have parentheses. In here I have negative and a negative. So simplifying that just to positive 3. Okay, continuing to simplify inside the parentheses. 3 plus 3 is 6. So I completed my first step in the order of operations. The next thing to do is evaluate powers. And I do have some terms that are raised to various powers. 3 squared is 9 minus 2 times 6 cubed. So 6 times 6 is 36 times 6 is actually 216. That took care of my powers. And the next thing is going to be multiply and divide. And when we do that, we always proceed from left to right. 2 times 216 is 432. Okay? Now, I have 3 times 3 is 9. 9 times negative 3 is negative 27. I'm going to rewrite this as 9 minus 432 minus 27. Finally, add and subtract, and this is going from left to right. So 9 minus 432 gives me negative 423 minus 27. So now I have another bit of subtraction to do. That's minus 423 minus 27 gives me negative 450. So again, the first step was substituting in 3 and negative 3 for x and y. The next step was to get rid of my grouping symbols. Evaluate the powers, multiply and divide going from left to right, and I just had multiplication here, and then add and subtract going from left to right to get negative 450. In the second example, again, we're asked to evaluate an algebraic expression, and here we have 3 variables, a, b, and c. So carefully substituting in each of these, a equals negative 1, so negative 1 squared. minus 2 times b, b is 2, times c, c is 3, plus 3 cubed. Here I have c squared in the denominator, so that gives me 3 squared minus 2 times a, which is negative 1, times b, which is 2. Since there was a lot of substituting, it's a good idea to double check your work. So a is negative 1, that's negative 1 squared, minus 2 times b times c, plus c cubed. All of that's divided by 3 squared, so that's c squared, minus 2 times a times b. So everything looks good. Now, the first thing I want to do is eliminate grouping symbols. Recall that in this type of a case, the fraction bar is functioning as a grouping symbol. So the whole numerator should be simplified, and the denominator should be simplified, and then I should divide one by the other. So starting with the numerator. Within the numerator, there aren't any grouping symbols. So I'm going to go ahead and go to the next step, which is to take care of powers. And negative 1 times negative 1 is 1. And then I have 3 cubed. That's 3 times 3 is 9, times 3 is 27. Okay, I can do the same thing in the denominator. I can just do these both in parallel. And so I'm going to evaluate the powers in the denominator. 3 times 3 is 9. And then I don't have any more powers. Okay, so I took care of that. My next step is going to be multiply and divide. Okay, so I have in the numerator 1 minus 2 times 2 is 4, and then 4 times 3 is 12, plus 27. So that took care of that step. Now in the denominator, I've got 9, and then I've got minus 2 times negative 1. So 2 times negative 1 is going to give me negative 2. Negative 2 times 2 is going to give me negative 4. Okay, so now I've taken care of all the multiplication and the division. Next step is to add and subtract, once again, going from left to right. So starting up here, next step is going to be 1 minus 12. So 1 minus 12 is going to give me 11, negative 11. So it's negative 11 plus 27. That's going to leave me with 16 in the numerator. In the denominator, I have 9 minus a negative 4. Well, a negative and a negative gives me a positive. So in the denominator, I actually have 9 plus 4, which gives me 13. So the result is 16 over 13. Again, starting out by substituting values for A, B, and C. And I have done that in this first step, and then I treat this fraction bar as a big grouping symbol, and I take care of the numerator and the denominator separately. You could have done them one at a time, or you can do the steps at the same time. So first, evaluating the powers. I did that in the numerator. I did that in the denominator, treating them separately. Multiplying and dividing. So I did my multiplication here and in the denominator. And finally, adding and subtracting to get 16 over 13. Example 3. The formula for the area of a triangle's area equals 1/2 BH. So this is actually the area equals 1/2 the base times the height of the triangle. Find the height if A is 32 and the base, B, is 8. Okay, here we're being asked to find the height, and we're given the other two variables. So let me rewrite the formula. Area equals 1/2 base times height. Now I'm going to substitute in what I was given. I'm given the area, I'm given the base, and I need to find the height. What I need to do is isolate h. So first, simplifying this, 32 equals, well, 1/2 of 8 is 4, so that gives me 4h. Next, divide both sides of the equation by 4. So 32 divided by 4 and 4h divided by 4 in order to isolate that. Well, 32 divided by 4 is 8. 4's cancel out on the right. And then just rewriting this in a more standard form with the variable on the left, the height is 8. So again, first just writing out the formula, substituting in A and B, which I was given, and then solving for the height. The temperature in Fahrenheit is F equals 9/5 C plus 32, where C is the temperature in Celsius. If the temperature is 78 degrees Fahrenheit, what is it in Celsius? Rewriting the formula and substituting in what's given. What's given is that the temperature in Fahrenheit is 78, and I'm looking for Celsius. So I always keep in mind what I'm looking for, what's my goal. And that is plus 32. So my goal here is going to be to isolate, to solve for C, to isolate that. Subtracting 32 from both sides gives me 46 equals 9/5 C. Now, in order to isolate the Celsius, I'm going to multiply both sides by 5/9. So when I do that, I'm going to get 5 times 46 is 230, and that's divided by 9. Here, that all cancels out. So rewriting this, Celsius equals 230/9. That's not usually how we talk about temperature. So simplifying that, if I took 230 and divided it by 9, I'd get approximately 25.5 degrees Celsius. So again, the formula for converting Fahrenheit into Celsius, or vice versa, is given. I substituted in 78 degrees and figured this out. So 78 degrees would be equal to approximately 25.5 degrees Celsius. That concludes today's lesson on educator.com, and I'll see you again for the next lesson.